Hello everyone. Now we are going to implement the naive-based classifier for continuous data. In this example, we're going to use the database from this website. Okay, so this is the place where I loaded or where I saved the data locally in my computer, and then we usually read the data with pandas, read CSV. So this data is about blood transfusion. So it's a small database. It has like 5 columns, just 4 features and the class that is binary. So let's copy this string. This is going to be the class name. As we saw in the slides, we are going to use the Gaussian distribution. For this example, using one component Gaussian is going to be enough. So let's define here the normal PDF or probability density function that will receive one data point, the mean and the standard deviation, and this is supposed to return the probability, right, or the density. So we are going to say the denominator from the Gaussian distribution in this variable is 2 times pi times the variance, and is the square root of all that. And the numerator is going to be the exponential of is minus x minus mean square divided by 2 times the variance. And we are going to return the numerator divided by the denominator. Okay, so now let's implement the naive-based classifier for continuous data. Again, as we did in the previous video, this is going to receive one data point, the training set or training data, and the class name. Here we are going to reuse some of the code we implemented in the previous video. This part, for example, is going to be needed. Right, because again we need to know the possible classes, the variables. We're going to need a variable or a dictionary to say the log probability of each of the classes, and now we iterate over all the classes. Again, we need to calculate the probability of the class, the prior, because we use it at the end of the product of all the factors, right? So here we select the cases in where the training data class name equals to C. We need to count this. Recall that the class is always discrete for classification problems, right? And we need to divide by the number of cases in our training set. Again, counting, right? We are going to accumulate the logarithm of the probability as we did in the previous video, starting with 0. And now we are going to iterate over the variables. So now we must calculate the conditional probability, which is the probability of x given the class per each of the variables, right? Okay, so the mean of our normal distribution is going to be we need to gather all the cases in where the class is C, but just index it in the variable, right? And we want the mean of this, and the standard deviation is almost the same thing. So now we want the probability of x conditioned in the class, and it's going to be our normal PDF of the data point only in this variable. Recall in naive Bayes we assume this conditionally independent, so this is why we only need univariate distributions, and this is why we implemented here the normal distribution just for one variable. We don't need a multivariate Gaussian distribution for naive Bayes in particular. So this is going to be the mean and the standard deviation. Actually, let's use the log of all that, and this is going to be the log of the conditional probability. So our accumulator now is going to add this result. Actually, we better do it this way, right? We don't really need the other variable. Now we need to update the log of the probability of the class, and it's going to be all the accumulated probabilities plus the log of this term, which is the probability of the prior class. And as we did before in our previous code, now we need to select the maximum element for classification purposes. So we just need to sort the dictionary and return the first element. Okay, so this is exactly as we did before. So just for a quick test, let's do this. Sorry, we have a mistake here. Okay, seems that is working. So as we did before, let's create a train set and a test set. We can copy all this. But here is this data. And now we need to create the confusion matrix, exactly as we did in this piece of code. Again, we need to change the name of the data frame. Okay, that's the confusion matrix, and let's do the classification. Also copying the code from the previous example. Seems that we don't have to change anything, right? And here we go. Okay, so that's it. It's mostly the same thing. The main difference with the previous video is that here we are using the Gaussian distribution. So instead of doing all the countings for the factors, for the conditional factors, we just need to get the mean and the standard deviation using the appropriate selections, and then calculate it with the normal probability density function. Again, we use logarithms, so we avoid the multiplication of very small numbers that usually can converge to zero very quick, and the rest is mostly the same.